So, just before starting, someone knows what is word embedding? Word-to-vec, fastText, you know something. Okay. So we're going to talk today about how to use word embedding to recover some missing information on our dataset. But before, let's introduce myself. I'm Gabriele Tani, lead data scientist at Vincu. I have a couple of masters, one in cryptography and communication, and the other one in statistical mechanics. I worked in other companies as backend developer, data scientist, and we played in the previous companies with physical engines as well. So fun stuff I do in Vincu is I work with NLP, survival analysis, backend developing, of course SQL, some recommender system, and well, I drink always a lot of coffee, and so if anyone wants to grab a coffee later to have a chat if he's interested about the talk, welcome. And well, we're also hiding, so if you want to ask about, you're more than welcome. What do we do at Vincu? Vincu is a job platform company. We focus mainly on sale, and generally job platform focus always on the concept of delivering interested candidates. However, our goal is not to deliver only interested candidates, but to find a good matching and find the best matching from both sides, from the candidate side and the company side. Why we focus on sale? Sale, if you think about, is a really, really interesting sector. We do not have anyone, there's no way of studying sale. What are the expertise of sale? Can you mention someone? It's somehow really intriguing also from a data science perspective, because you do not have only to look at the data, but also to understand the behavior of candidates and interpret text to find out different solutions. Just to give you an idea, Vincu is a startup, but we have about 700,000 candidates, 15,000 companies with about 2,000, 3,000 job publications per month, and we are in Mexico and Colombia. Well, there are many challenges, of course, that we are facing on everyday life. One of the simplest one, well, the biggest one, is improve the matching. The matching, it cannot be based, as I said, only on structured data, but it must be based also on behavioral data, and not only from companies, not only from candidates, but also from companies. We do not want to deliver candidates that are not interested in the company itself. One of the problems is that the matching we found out is not just about finding the good candidate and the interested candidate and so on. You have also to reach the candidate at the right moment. Of course, there's someone who's looking for a job now, but is not looking for it in 4 months. So and we have different kind of analyses trying to figure out what and how to contact the candidate at the right moment. Of course, candidates, another goal is not to invite or contact always the same candidate. Perhaps I should open a parenthesis here. How it works, the model. Every time there's a job publication, the Vincu staff approve the publication, and a selection algorithm runs and finds the best matching. This best matching receive an invitation. Of course, it's a little bit more complicated. The candidates are not receiving every time an invitation only because they match. But the concept is, okay, we're sending you the invitation with different restrictions, but how do we know when you're actually interested? Another problem is validate data from the user's perspective. And especially on the textual side, we have very often a lot of mistakes and so on. Of course, matching is as good as the input data we receive, but perhaps we can do something more. We can extrapolate some information, and sometimes what it happens is that, of course, the company is not perfect as any company, and we might change the model. We might put new questions. We might change some question. So how can we retrieve those data that from candidates that didn't have the possibility before to fill those data? Okay, one example is a few months ago we introduced, this is the registration form at the working experience, and we introduced new industries like bienes raíces, and we introduced also some new product and service, and we also introduced this question with these three selectable fields. Okay, but then how can we recover, for example, with all the previous candidates if they had selected bienes raíces or not? Well, looking at the textual fields like cargo and tareas y logros, we can extrapolate some information. So how do we process data? How do we process textual data? Computer is not capable, of course, of understanding words. Can we use one-hot encoding that is creating a very huge vector with 1, 1, and all zeros for all the other words in the vocabulary? Yes, we can, but nah. Dimensionality is really too big and increase with the size of the vocabulary. And of course, in average, a person doesn't use a huge size of vocabulary in his life, but is anyway too big. And the other problem is the notion of similarity. There is all the vectors are orthogonal, so there's no similarity at all. Everything has same distance from every kind of word. Okay, what about word embedding? We would like to have something like that. Vector, where the dimension is definitely much smaller than the vocabulary size, and distributed with some real numbers and possibly with some relationships among words. For example, we see that Rome and Paris are very close at the first position of the vector, and actually also in these other two, but not, and so on. And Italy and France as well have quite some similarities among vectors. Okay, then that's apparently a very cool idea, but what's word embedding? Word embedding is basically a map of words, or more generally of entities, from a certain vocabulary to a restricted vector space. One of the most famous algorithm of word embedding, word2vec, that it was developed by Michael et al. At Google in 2013. Glove, fastText, that it was developed by Facebook. Poincaré embedding, and well, every 6 months there are new models, and I'm sort of lost as well. So, okay, one of the basic concepts on which is based the word embedding hypothesis is the distributional hypothesis. That is, words that occur in similar contexts tend to have similar meanings. That is, context is approximated by the meaning is approximated by context. Another very nice property we would like of word embedding is some word analogies. One of the most famous example is the king minus man plus woman equal queen. And this might seem something really easy, but identifying a model that is capable of identifying relationship, not only grammatical relationship, but also semantic relationship, and it's not working just with king and queen and working worked. We have hundred and hundred of direction, and all those groups somehow keep the same direction if they make part of the same context. As I said, word2vec is a predictive embedding model that produces a distributional representation of the word, and it comes in two different flavors. Continuous backward word, that it predicts the word by its surrounding context, and skipgram that predicts the context given a word. This is continuous backward word that is basically given a window size of surrounding words. It should predict the word that is missing. And skipgram, the other way around, is finding the surrounding context. In general, skipgram is here we're talking about model that learn. Actually, we could argue that this is unsupervised learning. It is not. It's a self-supervised learning. That is, the algorithm learns by using its own output and input. That it can be considered almost the same, but slightly different. Skipgram is slightly slower, and apparently it works much better with rare words and with small amount of text. In our case, not. Continuous backward word, it works very well with high frequency word, and it finds a very interesting relationships, semantic relationships. So Glove and word-text and fastText. Glove is a statistical model. Differently from word2vec, it takes more advantage of the global context, and is definitely faster to train. However, if you find a way of training Glove, please tell me, because in months of investigation, it was not that easy at all. fastText and is basically an extension of word2vec, of the skipgram model. It doesn't take a word. It takes a different collection. For each word, it split that word in n-grams. That is, every single n-gram that it can compose that word is split, and then average to predict the word. The advantage of fastText generally is that is capable of dealing with words that are much less used in common life. So just to make it clear, all these models, fastText a little less, but are capable just of finding a relationship of what they learned. If you put new words, there's no way of finding any relationships, and actually it raises an error. So word2vec, we say in our investigation and our development, we use word2vec because globally it was not easy to train with our own dataset. And fastText, it gave us very, very bad results. And although people say that metric-wise fastText is indeed better, in our case it was not. Generally, all these models works, I must say, very well if you provide a huge amount of data. If you have, let's say, less than 100,000 words and 200,000 sentences, it doesn't work too much to use these models unless you do not use a pre-trained model. Okay, here we have just one of the most important library to use to training word2vec, fastText, and many other word embedding models. And well, of course, you can also use PyTorch, TensorFlow, whatever you want. Gensima is definitely much easier, and you do not need to make anything but just few lines of code, and it's ready. Here you can find, for example, some pre-trained models on Spanish. Okay, perhaps I didn't mention it. It's why someone would like to train his own model if there are pre-trained models. Models are trained on context. For example, you can train a model on a Wikipedia corpus or on a Twitter corpus. Do you think the information you can extrapolate from Wikipedia corpus is the same of Twitter corpus? No. You extract complete different context, you find different relationship, and you might also be sometimes interested in specific words that do not belong to this pre-trained model. And well, okay, so let's start. Here we have, in our model, we had to train, we have available 700,000 resumes and job titles. Of those job titles, 92,000 are unique. If you clean them up, make them, remove some useless words and so on, we'll use them to 72. And we have almost 200,000 distinct words. Okay. You think everything is fun? No. Spacey, it makes it much more fun, but pre-processing is pre-processing the text is very important, and it depends really a lot from the task you want to achieve. Removing how it works, Gensima or whatever library you want to use to train those models. Basically, you have to pass a list of sentences, and this list of sentences must be, each sentence must be a list of words. It cannot be an entire string. It wouldn't learn everything. So, of course, you have to make tokenization, And when you have a job title, you do not need to make sentence tokenization, but you need to make, of course, normal tokenization. But in a job description, you might want to tokenize also the sentence. Okay, Spacey is super. Is definitely the best choice if you want to do natural processing, language processing at production level. But you can use, if you like to play more around, also NLTK. However, although sentence tokenization in both is very good, sometimes you have to deal with sentences that are splitted and organized in a very different way from normal context. For example, in our case, a lot of people make copy and paste from a CV to our platform. And well, we have a lot of bullet points that we have somehow to tokenize to split sentences. With Spacey, this is super, super easy. You just preload the model, in this case, Spanish model, and you can add whatever the pipeline you want before or after the processing of the data. Okay, is sentence and tokenization and word tokenization enough? No. We have, of course, numbers in text. How do we deal with numbers? Numbers, of course, provide information, but if you have too much numbers, you cannot find relation among numbers. So there are, of course, many different approaches. There is someone who removes numbers, someone who prefers, like me in this case, to classify all number above 10 with an hashtag. So for example, in the case we want to classify a salary of 1 million, we know that it is 1 and 6 hashtag. And we can somehow compare numbers. Remove terms. Here I just put a small list of not Unicode terms. If you look at the list, I had to save it in a different file because it's something like really huge. And yeah, this is some other processing we want to do. Now, there's another problem. We might have sentences, words that are not represented by just one single token. That is, for example, key account manager are 3 tokens. And how can you identify that this is just one word and not 3 different words? So you have to create biograms or triagrams or n-grams. Generally, you stop at 3, that's with 3 you make 4, so it's fine. Apart biograms and triagrams and multiple words, multiple token words, you might have another problem. Acronyms. You know how many ways to write that it would be tienda. In our database, I don't know, but too much. And so what do? You somehow train with a small sample of those known way you have. And with entity recognition in Spacey, it's super easy. You just have to put the training sentences with target the acronym. And it's capable impressively to recognize most of the acronyms. Of course, it's not going to be capable of interpreting them. Well, okay. Depending on the task you want to do, in our case, we want to do classification, so we want also to remove adjective, nouns, and making lemmatization, because we want to extrapolate relationship, specific relationships among words. Well, okay. We prepare everything, and this is how we train the model. Word2vec document, we decide the size of the vector, train, and tell me the most, you remember the example king plus woman menos man? Here we have asesor plus mujer menos hombre. What do you expect? No, asesora. We forgot about something. Spelling. This is the way we found in our database and many, many more of writing asesor or asesora. But, okay, if you think about what I told you before, Word2vec learn from context. So what's interesting is that if all these words happen, somehow must be related to the original word, that the correct word, that it has definitely a higher frequency. So we can easily correct them with a Levenshtein distance. If there is short, if it's really short, we can correct it. Okay. What if we do not have enough data? In the case we want to anyway train our model, but it's not enough. Generally, the typical approach is you download a pre-trained model and you unify with your own model. Of course, what it happens is that it might have a different size of dimension. In this case, the pre-trained model at a vector dimension of 300, so you have to compress the dimension to 100 because we train it with 100. And you have your model. Of course, I wouldn't recommend that approach. If you can have your data, always better. Okay, let's look an example of our dataset. I don't show you the entire vocabulary because it's 200,000, so you wouldn't understand anything. But look, here the vector dimension, it was 100. We project it in 2 dimensions. And we're taking just few words, but what is interesting is that here we have inmobiliario, raíces, arriendo, inmuebles. Here we have an education theme. And key account manager, CAM, that is an acronym of key account manager, and call center, telemercadero, agente inmobiliario está related also to this. Agente, asesor, asesora comercial, asesor. We have a super interesting relationship. So, it took me training that model 10 minutes, processing the data 2 months. Okay, what's the idea? We introduce new fields, new question, and we want to predict, we want to backfill the information of the new fields to previous candidates that were not able to select this information because they were not available. I'll be honest with you. This is not the approach I'm using. It's the simplest approach, but we do not have time to go further. So let's just mention that as you can make word embedding, you can also do doc embedding. That is, you project the entire document in a collection of phrases inside a vector. This vector somehow, it has another inside vector that it contains words. But a very easy approach is, okay, we want to make a very simple classification. We compute the average of every word in the job title and every word in the job description. So we get only 2 vectors, one for the job title and one for the job description. Here we use some classification algorithm, very basic one. We're not using neural networks and all fancy things because the data were not enough, so we think small, and we simply predict with logistic regression for each category of the candidate that's selected. We select the output we train the model. Basically, let's assume we want to predict if a candidate selected vendo a empresas o vendo a personas. So we train a model with as output the candidate that actually sell to personas or companies, and making a logistic regression, we obtain the classification. Thanks, and if you have questions.
Questions, preguntas, las pueden hacer en español. Gabriel habla español, si alguien de pronto no sabe inglés.
Hola Gabriel, mi nombre es Daniel. Muchísimas gracias por tu presentación, fue muy ilustrativa. Me gustaría preguntarte, tú mencionaste el contexto en esto que era supremamente importante. ¿Cómo haces tú para poder entrenar estos modelos, dado que cada puesto o cada oferta de trabajo pertenece a una industria diferente que maneja terminologías distintas? ¿Cómo haces para...?
Eso es lo que...
Podríamos ahondar un poco más sobre eso, porque creo que pasamos muy rápido como por ahí.
¿A dónde? Bueno, digamos que exactamente esos modelos como aprenden con las palabras que intentan maximizar la probabilidad de una palabra en relación al contexto. Y esa probabilidad, claramente una palabra se encuentra en contextos diferentes. Y cada vez que se encuentra en contextos diferentes, distribuye su peso a las otras palabras también. Y más los contextos son diferentes, en verdad, en el contexto de venta, en general, de trabajo, todo es muy, muy parecido. Eso te permite de hacer mucho más viva las relaciones entre las palabras y encontrar más significado entre las palabras.
Bueno, yo creo que la segunda parte de la pregunta es más alrededor de cómo es el modelo de Vincuventas, porque creo que, según lo que vi, Vincuventas es como donde se centraliza la información de estos candidatos, ¿cierto?
Sí.
O sea, y el candidato es el cual llena esta información y es él el que inicia el proceso como de búsqueda de trabajo.
Bueno, acá tenemos dos metodologías diferentes. Sí, claramente el candidato se inscribe a la plataforma y tiene que llenar el formulario. Eso lo que hace es, la mayoría de las informaciones, hasta la experiencia laboral, son necesarias para poder conseguir trabajo. Y una vez que uno llena ese formulario, hay la manera para el candidato de aplicar directamente a las ofertas, y si aplica, pero de toda manera hay un algoritmo que selecciona los datos
y le
del
das
candidato.
la recomendación.
Sí.
Ok, o sea, la dirección es el sistema recomendándole trabajos a los candidatos.
Sí.
Ok, ya. No, eso era básicamente como... Ya, ahora entiendo lo del entrenamiento de las categorías, es en esa dirección. Gracias.
¿Más preguntas?
Hola. ¿Qué información consideras mínima o básica para poder hacer estas comparaciones entre los jobs postings o pues las ofertas y la información que proveen los candidatos? Y por ahí derecho también otra pregunta. No sé si entendí bien, pero también mencionaste que los candidatos pueden llenar ciertos formularios, pero entonces tu fuente de datos de los candidatos no solamente es su currículum, sino un formulario adicional. ¿Qué información capturas en estos formularios?
Y bueno, la segunda preguntamos sobre nivel de educación, es el formulario. Yo estaba hablando que el mínimo necesario es llenar hasta las informaciones laborales. Pero claramente preguntamos ciudad de residencia para geolocalizar la fuente de trabajos y nivel de educación y si tienes transporte y si hablas idiomas. Esas son las informaciones. Lo que hacemos generalmente miramos también al comportamiento de esos candidatos en el tiempo. Entonces, si un candidato no aplica o no se presenta a la plataforma por un tiempo, él pierde de importancia en recibir invitaciones. Y una vez que entra otra vez y quiere aplicar otra vez, recibe más invitaciones que están relacionadas a su perfil y a sus intereses.
Gracias. Y con respecto a la información que, digamos, la empresa buscando contratar publica, me imagino que eso también es un input para poder entrenar modelos y hacer los embeddings y todo eso. ¿Qué información le entregan al candidato de, mire, esta es la oferta?
Bueno, claramente las informaciones básicas, nombre de la empresa. Si está disponible, no, generalmente es por lo menos un rango de salario es necesario. La empresa no tiene que especificar el salario verdadero, pero un rango de salario que puede ser también muy grande es necesario seleccionarlo. Y el tipo de industria y productos y los servicios que trata la empresa y a qué está interesada la empresa. O sea, si una empresa es una empresa de sector financiero, pero podría ser también interesada a seguros, esas son informaciones. Generalmente todas las informaciones que machean, no sé cómo se dice, nunca lo aprendí, machear en español. Los candidatos están evidenciados, así que el candidato sabe porque, claramente tipo de contrato y ciudad y descripción.
Gracias.
Una pregunta dentro del contexto nuestro español latinoamericano, si en otros trabajos o en este mismo se te presentó el problema que nosotros, dependiendo del país en el que estamos, las palabras tienen incluso un contexto diferente. El mejor ejemplo es Colombia, que decimos una palabra regáleme para comprar. No sé si eso cambia de alguna forma los modelos o si has tenido experiencia, si eso afecta a los modelos en el tema de la similitud y cambia las probabilidades y eso.
Seguramente es una súper interesante pregunta y el problema es que en México no tenemos muchos datos, entonces yo entrené la mayoría de los datos sobre Colombia. Entonces Colombia gana. Regálame una.
Bueno, muchas gracias, Gabriel.